1982, the Surface Transportation Assistance Act required the Federal Highway Administration to report to Congress on the benefits and costs of a national intercity truck route network for longer combination vehicles. The California Department of Transportation volunteered to FHWA to conduct an actual over-the-road operational test of 3 longer combination vehicles. This presentation highlights the events of those tests. You will see the longer combination vehicles, which we also refer to as LCVs, traveling on the freeway and negotiating freeway interchanges. You will observe the LCVs in urban traffic, including arterials and intersections. The combination's mobility was tested at rest areas and way stations. Tests were conducted to check the efficiency of the vehicles in sudden braking situations. And off-tracking tests were conducted to check the additional space that these trucks require in turns. We also tested the LCVs for noise generation, fuel economy, acceleration, and movement and mobility on 2-lane roads. The test route covered approximately 1,200 miles of the California street, road, and highway system, stretching from the San Francisco Bay Area down through the San Joaquin Valley and into Los Angeles, then back up into the valley again. Each combination was operated over the same route, allowing observation of operation under a variety of conditions and a comparison between combinations under the same conditions. A request for proposal was sent to numerous trucking companies in the western states, asking for bids to supply tractors and trailers, an experienced driver, and the necessary permits. Viking Freight Systems of Santa Clara, California, was the successful bidder. Ed Bodie, a Viking employee, did all of the driving during the tests. He is one of Viking's line haul drivers assigned out of Sacramento.
We were looking for someone with a whole lot of experience in different types of equipment, primarily some good triples experience, somebody with a good, strong safety record from Pine for many years of driving, someone who would be able to do well under the pressure of the test, obviously the cameras, the escort vehicles, the highway patrol, and someone who's just has a real good attitude and wants to work with, or can work with a different group of people. I can speak for the 11 years with us. He's driven every different type of equipment we've got, and prior to that, he had a pretty good exposure in different types of equipment with other companies. So he's seen and driven almost everything that's on the road, and he's been able to handle it all, very well. His safety record, I think, speaks for that. He's a true professional. He's the kind of driver that we wish every truck driver was.
3 tests were conducted over a period of 3 weeks with the long vehicle combinations. The first being with a combination called the triples. The triples consist of a tractor, a 28-foot semi-trailer, and 2 28-foot trailers, with an overall length of 100.2 feet using a cab-over engine tractor, and a length of 107.4 feet using a 3-axle conventional tractor. The second week of testing was with a Rocky Mountain doubles combination, consisting of a 3-axle conventional tractor pulling a 48-foot semi-trailer and a 28-foot trailer. This combination had an overall length of 93.2 feet. The longest truck combination tested was the Turnpike doubles. It has a 48-foot semi-trailer and a 48-foot trailer and an overall length of 115 feet using a conventional 3-axle tractor. The 28-foot long, 102 inches wide trailers were made available from Viking's fleet. They were equipped with automatic brake slack adjusters, which were designed to keep the brakes adjusted automatically. 6 trailers were provided, allowing for testing of loaded and unloaded combinations. Each loaded trailer remained that way throughout the test to ensure that the weights were always the same. A number of single-axle converter gears were made available from the existing Viking fleet. These were 96-inch width dollies and generally also had the automatic slack adjusters. 2 48-foot by 102-inch trailers were provided by Dowdell Trucking. The sides and nose were constructed with fiberglass reinforced plywood. It was necessary to add a pintle hook and air brake connections, as a 48-foot trailer was not available with these features from the manufacturer. A 96-inch tandem axle dolly was used for the turnpike doubles combination. It required all new tires and all new plumbing and valving to bring it up to the quality of the other equipment. A total of 4 tractors were used during the test. 2 Kenworth K100 cab-over engine 4x2 tractors were made available from the existing Viking fleet. Both have a 120-inch wheelbase. The first one used was 3 years old and had 270,000 miles on it. It is equipped with an automatic transmission with a transmission speed retarder, disc brakes, and is powered by a Detroit diesel that produces 304 horsepower to the ground at 2,000 RPM. The second Kenworth cab-over was very similar to the first, except it was equipped with drum instead of disc brakes. It was used in the brake test to provide comparable data with other brake tests using drum brake factors. The third tractor used was a Ford LTL 9000 6x4 conventional tractor from the existing Viking fleet. It was a 1983 model with 90,000 miles on it. It produces 340 horsepower to the ground at 2,000 RPM. It is equipped with a Fuller 10-speed manual transmission. It has a 186-inch wheelbase. The fourth tractor was an almost new Freightliner with only about 9,000 miles on it. This tractor has a 210-inch wheelbase, is powered by a Cummins diesel engine coupled to a 13-speed manual transmission, and produces 480 horsepower to the ground. The California Highway Patrol was an important part of the test team and provided a number of services. The CHP officer is a mobile road enforcement officer trained to perform the critical item inspection for commercial vehicles. Each combination was inspected daily to ensure safe operation. The CHP officer also acted as an escort and provided traffic control services at times. Each combination was loaded as heavily as possible without exceeding the Formula B limits. The 80,000-pound upper limit was not considered. The triples were loaded to 111,000 pounds and were within 100 pounds of the Formula B maximum. The Rocky Mountain doubles were loaded to 106,850 pounds, within 250 pounds of the maximum. The Turnpike doubles were loaded to 122,650 pounds, which was within 2,250 pounds of the maximum. The combinations were loaded in accordance with WHI recommendations. That is, the heaviest trailer was in front, the lightest in the rear, and a balanced load in each trailer. Tests to certify braking distances were conducted on a partially constructed, unopened section of new freeway in the San Jose area. All tests were conducted on the same roadway section and were run both empty and loaded on dry and wet pavement. To simulate wet conditions, the pavement was watered by a construction water truck, applying a full width of spray immediately before the test, which would run the entire length of the braking distance. The combinations tested were the same ones used on the over-the-road tests. The asphalt was 3 to 6 weeks old and had not had traffic on it. The coefficient of friction was measured with a friction analyzer. Each combination ran in the middle of the 37-foot wide pavement. The stopping speed was measured with a radar gun, and radio communication allowed the driver to increase or decrease the approach speed.
55. 55. Looking good, 55.
Each combination was braked at 3 different speeds, 25, 45, and 55 miles per hour. An electromechanical gun is attached to the tractor, which shoots a blank shell when the brake is applied, which allows for the actual stopping distance and not accounting for the driver's reaction time. Only the actual stopping distance was measured from the point of brake application to the actual stopping of the combination.
As noted earlier, several tests were conducted over the course of 2 days. The single 48-foot semi was tested along with the 3 primary combinations. A separate film was made of the braking tests, and a written report details the actual speed, pavement condition, and stopping distance of each test. What we wish to do here is show some of the tests.
All braking tests were not completed with the turnpike doubles. The load had been bulkheaded to obtain maximum loading. Then, on the first loaded brake test, there was a uniform shifting of pallets, collapsing the bulkhead and breaking through the trailer nose.
Well, the only thing I could have, so we were going 25 miles an hour on a dry brake test, and I applied the brakes, and evidently the bulkhead came loose in the rear trailer here, and the load just shifted forward and went to the nose of the trailer.
Would that happen very often, or just a freak accident?
Well, if the bulkhead's put up properly and stable enough, and most of your loads, you don't really have bulkheads. Your load is all the way to the nose of the trailer, but due to the weight of these books and things like that, we had to keep the load back so you don't overload your axles.
This does indicate that substantial attention should be paid to the actual loading and tie-down procedures. In these tests, the combinations varied from stopping straight to a movement of 5 feet sideways. Movement occurred to both the right and the left, although most variation appeared to the left, in the direction of the pavement cross slope. Generally, each combination took slightly more distance to stop under wet conditions, but not significantly more. When loaded, each combination took slightly more distance to stop than when empty, but not significantly more. The triples with 2 axles took less distance to stop than the triples being pulled by the 3-axle tractor. The empty long vehicle combinations stopped in generally the same distance as the 48-foot semi-trailer. Acceleration tests were also conducted. Measurements were taken using a radar gun and stopwatch to determine a time versus speed comparison. Off-tracking tests were conducted in the Viking Yard in Santa Clara, California. Off-tracking is defined as the additional width over and above the truck width required by a vehicle when making a turn. A Caltrans survey crew laid out 60, 80, and 100-foot radius curves over a 180-degree central angle on the parking lot surface. Central angle increments of 30 degrees were marked on the curves. Each test combination entered the curve on the tangent. The driver steered the outside edge of the left front tire on the curve, then proceeded to drive around the curve, exiting the curve on the tangent. The single 48-foot semi was tested along with the 3 test combinations. While the combination moved around the curve, the path of the right rearmost tire was continuously marked on the pavement. The distance from the appropriate curve center to the rearmost tire mark was recorded at 30-degree increments, and the difference between this recording and the curve radius was measured as the amount of swept width. The off-tracking was generally at a maximum at around 120 degrees of the central curve. The off-tracking for each combination decreased as the curve radius increased. The off-tracking did increase as the combinations went from 48-foot semi to cab-over triple to conventional triple to Rocky Mountain double to turnpike doubles. These measurements agree with the over-the-road observations made of the different combinations at the same locations. Complete test results are in the written report available from Caltrans. The test was intended to show the actual operational characteristics of each combination, and also to show under what conditions the operation might be restricted and why it might be restricted. Doubles also experienced the same problem. Such actions would result in accelerated deterioration of shoulder edges and increase the chances of striking roadside objects. consistently crossed over and climbed the curb on many of the older interchanges on the designated system. It was not unusual for one tire of each rear dual to ride the top of the curb with the other tire being suspended in the air. This situation would create significant pressure on both the tires and the curbs, creating the potential for very rapid curb deterioration and tire blowout. The turnpike doubles had significant problems on existing interchanges and would affect substantial pavement edge maintenance or new facilities design standards far exceeding those existing today. This test was conducted to see how the combinations would operate on the open road. Constant 4 to 6 inch total sideways displacement movement of the middle portion of the trailer combination. The trailer combination had a sine wave or serpentine appearance with maximum movement occurring between the second and third trailers. There was generally little apparent sideways movement of the rear of the third trailer. The serpentine action was particularly noticeable on I-580 and I-5. This 125-mile stretch of freeway consists of a modern design standard 4-lane freeway in rolling or flat terrain in totally rural areas. They look like they are welded together. There was absolutely no whip or sway observed. The turnpike doubles had the same operating characteristics as the Rocky Mountain doubles. No open road problems were observed with this combination. All three long vehicle combinations were run through significant amounts of urban travel conditions to test the feasibility of operation in these areas. This phase of the test had 4 elements. 1, operation on urban freeways. 2, impact on urban ramp traffic entering or leaving the freeway. 3, operation on urban arterials. 4, operation in urban arterial intersections. It appears that the viability of the long vehicle combinations on mainline urban freeways depends almost exclusively on the skill of the driver. The length or configuration of the vehicle is not a major factor. The driver took the approach of driving a steady line. That is, an absolute minimum number of lane changes, making the necessary lane changes far in advance. trying to maintain a constant speed, and not rushing through the urban areas. There were a few instances where a vehicle was alongside the test truck and had to brake or accelerate when a lane drop occurred. There seemed to be no real problems encountered in urban freeway traffic, and again, this is felt to be mainly attributable to the skill of the driver. Problems for the driver increased. Speeds are slower on arterials, thus the distance between vehicles is less. Signals, which create packs of traffic, rather than spreading it out. This gave the driver less of an opportunity to make many movements for the test, although each combination did have more difficulty than shorter trucks or transit buses. The turnpike doubles, and to some extent the Rocky Mountain doubles, had some difficulty entering and exiting the Viking Yard in Modesto. The facility is on Crow's Landing Road, a 4-lane arterial, with a striped dual left turn lane and a curbed 30-foot wide entrance and exit. On a right turn exit from this yard, the turnpike double encroached about 4 feet into the dual left turn lane. This required stopping the traffic on Crow's Landing Road so the vehicle could make the turn. It is doubtful that the combination could make this move safely without considerable waiting for a traffic opening. At many intersections, and especially for the turnpike doubles, left turns were not made from the left turn pockets. The reasons were that the left turn pockets were not long enough for the test vehicle to get into straight. There was usually another vehicle in the pocket, which further reduced the amount of space, and the driver generally needed all the room he had available. Traffic being caught between the long combination and other fixed objects. Oncoming traffic tended to shy away from the center line. The one exception was the cab-over triple. The modifications could range from simply restriping the truck parking areas to new construction of parking areas solely for the longer combinations. The procedure is simply to pass over the scales, then continue back onto the freeway. There are no problems. However, occasions will arise when a more detailed inspection, such as an equipment check, would require other maneuvers. Two grades to test the long combination's hill climbing ability. The measurements were made on I-580 at Altamont Pass. Eastbound is a 4% grade, and westbound is a 3% grade. Measurements were also taken on the Grapevine on I-5. Northbound and southbound are both 6% grades. Radar readings allowed simultaneous checking of a large sample of 5-axle trucks against which the test truck's speeds could be compared. A summary of these speeds can be obtained in the written report. The far right lane is when the slower trucks use the far right lane. Then the faster trucks use the lane left of that one to pass, and the autos have the inside 2 lanes for the same maneuvers. But the long combinations were so slow that even the slow conventional trucks had to pass them. When this happened, the faster trucks took one of the lanes usually reserved for the automobiles, leaving the cars with only 1 lane. This condition substantiates the need for a reasonable minimum speed on these grades. The long combinations were also observed going down the 6% Grapevine grade. With both the triples and the turnpike doubles, there was considerable smoking of the brakes. However, there was never a loss of brakes. On the triples, this was later discovered to be caused by uneven brake pressure throughout the braking system. The only significant rain occurred from Altamont Pass on I-580 over a distance of about 20 miles. The rain was heavy enough to observe the performance of the long vehicle combinations on the open road in inclement weather. neither the loaded Rocky Mountain doubles nor the turnpike doubles experienced any handling problems because of the wet pavement. The Rocky Mountain doubles combination was outfitted with spray deflectors on the 28-foot trailer, but none were on the 48-foot trailer. The spray deflectors proved very effective. It was not unusual for an automobile to pass the 28-foot trailer at normal speed and then hesitate to pass the 48-foot trailer because of the spray generated by the wheels. Although we were prepared to test the effects of wind on the empty combinations, it was not possible because the wind did not exceed 8 miles per hour during each of the 3 test runs. A variety of conclusions can be made when comparing the longer combination vehicles with other existing 5-axle trucks. Combinations and include mobility on urban freeways and arterials, freeway facilities, and on grades. The extra weight behind tractors designed for legal loads also had a definite effect on the acceleration of the vehicles. We also found that the differences do exist between the 3 combinations tested. That is, there are different handling or maneuverability characteristics for each. The more prominent problem with the triples, which could prevent their universal operation, was the constant whip and sway, which could create problems in dense traffic conditions. The triples, however, proved as maneuverable as the largest combinations legal in California on the designated system. The Rocky Mountain doubles encountered none of the road problems associated with the triples, but they did have a difficult time maneuvering through existing interchanges and intersections. They negotiate some interchanges within the confines of the roadway. This again would result in pavement and sign damage, even more severe than with the other combinations. The handling and maneuvering problems were even more magnified off the freeways in the urban areas. It is probable that special provisions may be needed for long vehicle combinations, or thought should be given to special operating conditions and limitations.
In conclusion, these tests indicated the need for diligent governing procedures with respect to allowing longer combination vehicles on the designated freeway system. The vast majority of the system was designed to accommodate a vehicle now 2 generations old. Further increases in truck combination size must be carefully evaluated with respect to the safety of the motoring public and possible damage to the highway system. It was the intent of these tests to point out the operational characteristics and limitations of the longer combination vehicles in today's traffic conditions.
As far as the triple trailer is concerned, for the interstates, they'd probably be fine, but anywhere else other than on the interstates, with drop-off points along there, I couldn't see them being used. It'd be too much of a traffic hazard, too much congestion. They're hard to handle.
Would you like to see them in California, though, besides going into the city limits?
Yeah, on the interstates, it'd probably help the freight haulers, but as far as I'm concerned, I wouldn't want to pull 3 of these ammonia trailers, no. That's for sure.
They're fine with me on the freeway. When you get on another 2-way highway, it's a little different thing, but on the highway, on the freeways, they're fine with me.
Would you like to see them in California? Do you think it would help our trucking industry at all?
Not that they will save fuel.
What do you think of them on city streets?
Well, city streets are going to have problems, but as far as the freeways and your main highways, there's no problem. Because a setup like that will turn sharp around a corner than this truck will here. The trailers follow better.
Have you got any opinion about running trucks this long on the road today?
Well, yes, really. I think that trucks that are getting too long and too much load are detrimental to the highways. And although they do pay their fee and taxes on it, that still doesn't help the highways to keep them in condition. And they could be somewhat dangerous, perhaps, as far as passing and things like that.
I think triples are fine if you got a wake driver and he holds the speed limit. I think there's no problem. Main problem would be is in the city, and that's just going around the turns. Otherwise, freeway straight away, and you just go.
Anytime a truck's got a pup on the back of it, I think they're putting a man out of a job. I'm not really that crazy about it.
You think they're pretty safe, though, or?
I've seen them flip in mountain country, slick weather, high winds. They're not safe, no. But normal driving conditions, they're as safe as any other truck.
Now that you had a day with this, what would be your choice out of the three?
Out of the three, it'd be either triples or your Rocky Mountain doubles. As far as to be more movability in more congested areas and things like that.